a new session on Operation Research online lecture series. Myself Tushar, Thakar, Assistant Professor in Mechanical Engineering Department at LJ Institute of Engineering and Technology. In last lecture, we learned or we understood a simplex method. So, main three methods we have to use is simplex method, graphical method, and big M method. Big M method, today we will learn a big M method, and big M method that is known as a advanced or modified simplex method. Why? Because when we apply a simplex method, whenever a decision variables are more than 2, means x1, x2, if x3 as a decision variable introduced into the data or the problem and linear programming problem, what happened? We can't apply a graphical method on that. So we have to use a simplex method. But the question is that when we use the big M method, when we can't solve a simplex method of a problem. So in data, if inequality sign, always in simplex method inequality sign will be given as less or equal to, right? Only less or equal to. But in data, they mention as greater or equal to sign or only equal, greater or equal to sign and only equal to sign. At that time, you can't solve that problem by using a simple simplex method, right? You have to apply a advanced simplex method, or you have to apply a modified simplex method, that is a big M method for solving that problem. So for slack variable, for simplex method, we have to introduce a slack variable. Here big M is denoted as a artificial variable, means we have to introduce here a M as an artificial variable into the data and into the equation and LP formulation or modified LP formulation. We can solve that equation and we can find as a solution of that problem as a part of our optimum value, right? So let's see what is the big M method, when we are used, what it indicates, how we solve it, what are the steps for solving a big M method. Let's see in today's session. So big M method. So in big M method, it is a solving a linear programming problems. It is one of the oldest LP techniques. Big M methods refers to a large number associated with the artificial variables. And the big M method introduces a surplus and artificial variables to convert all inequality sign into the standard form, right? So we have to introduce here surplus variable and artificial variable. Here we have to introduce two variables. So what happens if you introduce a one variable, so you have to add, then we have coefficient 0, so we can minimize that variable. But we have to add two variables, so what we have to do, we have to add a plus one variable and we have to minus another variable to balance that equation, right? So let's see next example. In example detailing, first we have to see a simple steps for big M method. So first, what is a step? First we have to add artificial variables and step variables in the model to obtain a feasible solution. Clear? Second, added only to the greater than or sign or equal sign in a constraint. Keep in mind at where we have to add artificial variable. Here important point, added only where. So it is important, and it is this step maximum guys do mistake. Maximum guys do mistakes and they are failed to solve a problem. So at where we have to use, or at where we have to adding artificial variable, at that we can we have a greater than or equal to sign, or at we have a equal to sign as a constant part, or at RHS part, right? At that place we have to introduce a artificial variable, and we have to introduce that artificial variables in form of that equation. Suppose we have get a set greater or equal to sign in that equation, we have to introduce in terms of a second equation as m2. We can't introduce as m1, right? So let's a value of m is assigned to each artificial variable, right? Value of value of m we have to assign. The transport problem is then solved using a simplex eliminating the artificial variables. First we have to modify, or we have to convert that equation by introducing a surplus and artificial variables, and then after that formulation we have to solve by a simplex method only. That's why we say that this is a modified simplex method. This is a simplex method. We have to solve this method by the simplex, but we have to introduce before that a m set variable by eliminating a greater or equal to sign. Clear? So solve that modified LPP by a simplex method until any one of three cases may arise. First case, if no artificial variable appears in the basis and the optimality conditions are satisfied. Means here we have to eliminate a m variable from the basic, right? Second case, if at least one artificial variable in the basis at 0 level and optimality condition is satisfied. And for case 3, if at least one artificial variable appears in the basis at a response level of the optimality condition is satisfied, then the original problem has no visible solution, right? Clear? So we have to introduce that slack variable and solve that problem, and we have to consider all three cases for solving that problem. Main 4 drawbacks of big M method. First is, how large should M be? Means up to a large equation we have to introduce a large M, that is complexity in the problem. Second, if M is too large, serious numerical difficulties in a computer. Big M method is inferior than a two-phase method, and here the feasibility is not known until optimality. Here 4 main drawbacks of big M method. Clear? So this is a basic theory of big M method, how we solve a LPP problem which has a greater or equal to sign, and how we solve that problem by simplex method by introducing a big M into that, and artificial variable and surplus variable into that, and we solve that problem by simplex method. That's why we know as a modified simplex method as a big M method. So in next lecture we will learn and we will solve this problem by using a big M method. It is also known as a penalty method because we have to apply a penalty as artificial variable and surplus variable. Clear? So as we see that in this equation we can see that a greater or equal to sign is introduced. So we can't solve this problem by simplex method. So we have to implement a modified simplex method. Clear? So we will see in next lecture, and we will solve this problem in next lecture. Thanks for watching.